So welcome back to RS Academy. So we are discussing fourth chapter, that's carbon and its compounds. In that I have done so many videos. Please go through that video. In this video, I would like to explain isomerism. So what is meant by isomerism and its classification? Get ready, students. Right, isomerism. Isomerism. So before going on talk about isomerism, let me say a few words about isomers. What is meant by isomers? Isomers. Make a note. Isomers. Isomers. Those organic compounds having same chemical formula and different structural formula. These are considered as isomers. Those organic compounds having same chemical formula or same molecular formula and different structural formula. Or instead of that you can say those organic compounds having same chemical formula but different physical and chemical properties. These compounds are considered as isomers. This phenomena is called isomerism. Make a note. Those organic compounds having same chemical formula and different structural formula these organic compounds are considered as isomers and this phenomena is called isomerism. In class 10 chemistry we have only structural isomerism. In plus 1 you will get stereoisomerism and structuralism in detail. So in case of class 10 chemistry we have only structural isomerism. In that position isomerism, chain isomerism and functional group isomerism. Okay, so isomers means those organic compound having same molecular formula and different structural formula, or those organic compounds having same molecular formula and different physical or chemical properties. These organic compounds are considered as isomers. This phenomena is called isomerism. So let us have an example. Look at that. Butane. Let us draw the structure of butane. But plus ane, 4 carbons with single bond between carbon and carbon. 1, 2, 3, 4. Remaining valence of carbon must be filled with hydrogen. CH3, CH2, CH2, CH2. This is a butane. Especially it's a N-butane. So that means there is no branches, it's a straight chain. It is called N-butane. Okay, chemical formula C4H10. And I would like to write this structure like this: CH3, CH, CH3 and CH3. I made change in the branch, chain. I made change in the chain. So chemical formula this compound also C4H10. Same chemical formula but different structural arrangement. Different structural isomer. Different structural arrangement. So those organic compounds having same chemical formula and different structural formula, these are considered as isomers. This phenomena is called isomerism. Is it clear to you? Isomers means those organic compounds having same chemical formula and different structural formula, considered as isomers. This phenomena is called isomerism. This is N-butane. This one is 1, 2, 3, 2-methyl propane. 2-methyl propane. Let me write here 2-methyl propane. So 2-methyl propane is isomer of butane. So that's why it is also called isobutane. 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 So butane and 2-methyl propane both are isomers because they have same chemical formula but they are differ in the structural arrangement, structural formula. So these are called isomers. This phenomena is called isomerism. Make a note. Next one, types of isomerism. So isomerism are mainly two types: structural isomerism and stereoisomerism. So according to our syllabus, let us have a talk structural isomerism. Structural isomerism means having same chemical formula and different arrangement of the atoms in a carbon chain. These are called structural isomerism. In that one, first one will be chain isomerism. Chain isomerism. Chain isomerism. Chain isomerism. Chain isomers having same chemical formula but different parent chain. Same chemical formula and different parent chain. So this phenomena is called chain isomerism. A chain isomers means, please make a note, chain isomers. Chain isomers. Chain isomers. So let us have a talk what is chain isomerism and examples. Chain isomerism or chain isomer. Chain isomers means those organic compounds having same molecular formula, same molecular formula and different parent chain. Different in parent chain. Different in parent chain. Chain isomers are nothing but organic compound having same molecular formula, different in parent chain. So these phenomena is called chain isomerism. So we need to make a change in the chain, parent chain. Example, so let us take pentane. Pentane. Pentane chemical formula C5H12. Structure will be CH3, CH2, 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 CH3. CH3, CH2, CH2. This is called N-pentane. N-pentane. N-pentane means there is no any set of methyl groups on parent chain. So the normal pentane N-pentane is called as N-pentane. Right? So now I would like to make a change in the parent chain. I would like to convert N-pentane into different like this. Listen to me. CH3, CH2, CH3. Here I would like to add one more carbon. Right? Listen carefully. This is a parent chain. This will be considered as branch. Right? Chemical formula will be same. That is C5H12. There is no change in chemical formula. But parent chain is a chain. This is a parent chain will be pent. Here parent chain 1, 2, 3, 4 but. The name of this compound is 2-methyl butane. 2-methyl butane. 2-methyl butane. So 2-methyl butane is an isomer of pentane. 2-methyl butane is isomer of pentane. Especially chain isomer. Chain isomer means same chemical formula differ in their parent chain. Here parent chain is pent, here parent chain is but. So differ in parent chain. Same chemical formula differ in parent chain. So these are called chain isomers. This phenomenon is called chain isomerism. One more structure I would like to draw regarding pentane. Right, let me draw here. Right, CH3, 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 CH3. Right, this is the parent chain. 2 comma 2 dimethyl, 2 comma 2 dimethyl propane, 2 comma 2 dimethyl propane. So this one also having chemical form same chemical formula same chemical formula and different parent chain. Here parent chain is prop, here parent chain is but, here parent chain pent. So those compounds having same chemical formula differ in their parent chain. These are called chain isomers. This phenomena is called chain isomerism. How many chain isomers can be drawn for pentane? 3. N-pentane, 2-methylbutane, 2 comma 2 dimethyl propane. So N-pentane, N-pentane, isopentane. This is called isopentane. And third one will be neopentane. Neopentane. This is considered as neopentane. Neopentane. Please make a note. So N-pentane, isopentane, neopentane. So these three structures having same chemical formula but differ in their parent chain. Differ in their parent chain. Here, why should we call this as an isopentane? So those carbon compounds having one methyl group next to the terminal carbon. The carbon which is next to the terminal carbon is called isocarbon. So that's why it is called isopentane. Total 5 carbons, isocarbon is there. So that's why it is called isopentane. Here, if the carbon which is next to the terminal carbon consists of 2 methyl group, that is called neo. So this is considered as neopentane. So this iso, neo and N-pentane, isopentane, neopentane. Make a note. Butane and pentane. Butane, pentane. I would like to give list of isomers for can be drawn for butane and pentane. So butane formula C4H10. You will get two isomers. One is N-butane CH3CH2 CH2CH3. This is called N-butane. And second one is isobutane. That is CH3CH CH3CH3. This is called isobutane. Isobutane is also called 2-methyl propane. 2-methyl propane. 2-methyl propane. Then what about pentane? Pentane chemical formula C5H12. You can draw three isomers for pentane. One is N-pentane, CH3, CH2, 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 CH3. Right, pentane. So N-pentane, N-pentane, you can write this CH3, CH, CH2, CH2, CH3. Sorry, this one is 2-methyl, 2-methyl butane. 2-methyl butane is called isopentane. Isopentane. Next, third one will be CH3, 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 CH3. So this is called neopentane. 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 IUPAC name will be 2,2 dimethyl propane. 2,2 dimethyl propane. So these are the chain isomers of pentane and butane. Right? Butane, two isomers, one is N-butane and 2-methyl propane, also called isobutane. For pentane, you will have 3 N-pentane, 2-methyl butane, also called isopentane, 2,2 dimethyl propane, also called neopentane. So you will get questions in the examination like this: how many chain isomers can be drawn for pentane, or how many structural isomers can be drawn for pentane, and so what is the isomer of butane? So 2-methyl propane is the isomer of butane. So what is the IUPAC name of neopentane? What is the IUPAC name of isopentane? So these kind of questions you will get in the examination. So this is a few words about chain isomerism. Now let us have a talk positional isomerism. Okay, right. Make a note. Next one, position isomerism. Position isomerism. Position isomerism. Those compounds having same molecular formula or same chemical formula and differ in the differ in the position of double bond or triple bond or branches or functional group. These isomers are called positional isomers. This phenomena is called position isomerism. Position isomerism means those organic compounds having same molecular formula but differ in differ in the position of double bond or triple bond, substituents, nothing but branches, or functional group. So are called positional isomers. This phenomena is called position isomerism or position isomerism. Example: chloropentane. Let us take chloropentane. 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 CH3, CH2, 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 Cl. So this one chloropentane. We should give numbering: 1, 2, 3, 4, 5. This is called one chloropentane. One chloropentane. So I would like to change the position of the chlorine. So look into this. CH2, CH, CH3, Cl. Now this will be 2-chloropentane. Because of numbering must be done from this side. 1, 2, 3, 4, 5. 2-chloropentane. So I would like to draw one more structure. CH3, CH2, CH, CH2, CH3. This is called 3-chloropentane. 3-chloropentane. 1, 2, 3, 4, 5. 3-chloropentane. 3-chloropentane. This is 1-chloropentane. 2-chloropentane. This is a 3-chloropentane. Chemical formula is same. So let us check. How many carbons? 1, 2, 3, 4, 5. 5 carbons. Hydrogens 5, 7, 9, 10, 11. Chlorine 1. This is a chemical formula. Then what about this? Let us check how many carbons are there. Are you following, my dears? Right? 1, 2, 3, 4, 5. Okay. Hydrogens 5, 6, 7, 8, 9, 10, 11. Okay. Right. Then what about this one? 1, 2, 3, 4, 5, 5, 7, 8, 11. So same chemical formula, but these three are differ in the position of the chlorine. Position of the chlorine. Here chlorine at first carbon. In this structure chlorine at second carbon. In this structure chlorine at third carbon. So those compounds having same chemical formula but differ in their position of the double bond or triple bond branches or substituents or functional group, they are called positional isomerism. Positional isomerism. So 1-chloropropentane, 2-chloropentane and 3-chloropentane. These three are considered as positional isomers. Positional isomers. Okay. So let us take one more example. Make a note. Let us take butanol. Sorry, butanol. Butanol is an alcohol. CH3, CH2, CH2, CH2OH. This is the structure of butanol. So this is one butanol because of alcohol group is present in first carbon. So one butanol. One butanol. So two butanols also present. So CH3, CH2, CH, CH3. This is 2-butanol. 2-butanol. But we should not write 3-butanol because of if you place OH group in this carbon, numbering must be done from this side. So that's why there is no 3-butanol. So 1-butanol and 2-butanol. Same chemical formula, but these two structures are differ in the position of the OH group. Differ in the position of the OH group. These are called positional isomers. This phenomena is called positional isomerism. Right? So butanol. So let us take one more example. Butene. Butene. Butene structure CH3, CH2, CH double bond CH2. This is a butene. So especially this is 1 butene because of double bond is at first carbon. 1, 2, 3, 4. 1 butene. So I would like to place this double bond in this carbon. CH3 double bond CH. This is called 2-butene. 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 So same chemical formula but differ in the position of the double bond. So this also called positional isomerism. But there is no change in the parent chain. But, but. So there is no change in parent chain. So same chemical formula but differ in the position of the double bond, the position of the triple bond, position of the functional group and position of the substituent. These are called positional isomers. Okay, make a note. Next one, functional group isomerism. Functional group isomerism. Those structures having same, those organic compounds having same molecular formula but different functional group. The different functional group. These are called functional group isomers. This phenomena is called functional group isomerism. For example, listen carefully. I have one chemical formula that is C3H6O. C3H6O. With the help of this chemical formula, I can draw structure like this: CH3, CH2, CHO, and CH3, COCH3. Listen carefully. This is called propanol. This is called propanol because of here functional group will be aldehyde. So this is called propanol. Here functional group is ketone. So same chemical formula but these two are having different functional group. So that's why these two are called functional isomers. So propanol and propanone. Propanol and propanone both are considered as functional group isomers. Functional group isomers. So those compounds having same molecular formula and different functional group is considered as functional isomers, functional group isomers. This phenomenon is called functional group isomerism. Okay, right. Now, only few combinations are possible. That means we can convert aldehyde to ketones and ketones to aldehyde. In a similar way, acids to esters, esters to acid. At the same time, we can convert alcohol to ethers and ether to alcohols. But we have only 5 functional groups according to our syllabus, that is halo groups. Next one, acids, esters, aldehydes, ketones and alcohols. Okay, so according to our syllabus we have only two possibilities to convert the to write the functional group isomers. One is, make a note, one possibility that is you can write or you can convert acid to esters and convert aldehydes to ketones. You can convert alcohols to ethers and alkynes to dienes. Dienes. So these are the possible conversions in case of functional group isomers. And but according to your syllabus, there is no ethers. But I would like to give one example for that. No need to worry about it. So acids, we can convert the acid to esters, aldehydes to ketones, alcohol to ethers, alkynes to dienes. Okay, right. Make a note. Let us discuss about acids, conversion of acids to esters. Conversion of acids to esters. Right. Listen carefully, my dears. Right. C4H8O2. So this is the given compound chemical formula, C4H8O2. By using that, we can draw functional group isomers, C4H8O2. So remember once. So how many functional groups are there according to your syllabus having two oxygen atoms? Right, only two. One is acids and second one is esters. And acids and esters only consist of two oxygen atoms. Please remember that. So that means by using this formula we can draw acids and ester structures. Okay, right. First of all, let us draw acid and followed by esters. Look at that. 1, 2, total 4 carbons. COOH. This is acid. Right? CH2, CH2, CH3. Let us check chemical formula. 1, 2, 3, 4 carbons, hydrogens, 3, 5, 7, 8, 8 hydrogens, oxygens, 2, C4H2. So what is the name of this compound? Butanoic acid. Butanoic acid. Butanoic acid. Okay, ma? Right. Now let us write ester. Listen carefully. Acids consist of functional group COOH. Esters are COOR. This is a general formula for functional group of esters. Right. Carbon, C double bond O, CH3, sorry, CH2, CH3. Total 4 carbons. C4, 1, 2, 3, C4, 6, 8, H8, O2. Same chemical formula. But this is ester form, this is acid form. What is the name of this compound? It will be alkyl, it will be OH. Ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. So by using the chemical formula C4H8O2, we can draw two possible structures. One is butanoic acid, second one is ester, that is ethyl ethanoate. Ethyl ethanoate. So ethyl ethanoate and butanoic acid both are considered as functional group isomers. Functional group isomers. Okay, ma? Right. Make a note. Next, one more example. Let us take second conversation, that is C4H8O. C4H8O. Here C4H8O. How many oxygens are there? Only one. So remember once. How many functional groups are there with single oxygen atom? Alcohol, ketones. Alcohol, ketones. According to your syllabus, alcohol and ketones. Okay. So it's not possible to draw ketone structure. Sorry, alcohol and ketone, But here it's not possible to the alcohol structure. Alcohol structure. It is a sorry. We have three functional groups. One is aldehyde, and second one is ketone, and third one is alcohol. It's not possible to draw the alcohol structure. Okay, because of it's not exist formula. Let us check once. 1, 2, 3, 4 OH, CH2, 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 CH3. Here, how many carbons? 4 hydrogens, 5, 9, 6, 9, 10, and O. Right? So, we can't draw the alcohol structure by using this chemical formula C4H8O. But we can draw aldehydes and ketones. Because of aldehydes ketone general formula CnH2n CnH2n. So by using this chemical formula, we can draw aldehydes and ketones, not a alcohol. Please keep that point in your mind. Right. Let us draw the structure. Either aldehydes or ketone. Aldehyde means CHO. This is a functional group for aldehydes. Ketones, C double bond O group must be present between two carbon atoms. We have 4 carbon atoms. 1, 2, 3, 4. Remaining valency must be filled with hydrogens. CH2, CH2, so CH3. Right? This is called butanol. Butanol. Then what about this one? Keto group. 1, 2, 3, 4. C double bond O group must be present between any two carbon atoms, here or here. That's up to you, not a problem. So remaining valency must be filled by hydrogen. CH3, CH2, CH3. Right? This is called 1, 2, 3, 4. 2-butanone, or also you can call butanone. So butanone and butanol, these two are functional group isomers. Butanone and butanol, these two are functional group isomers. Okay, great. Next one, C3H8O. This is a given chemical formula. Right. How many oxygens are there? 1. So possible functional groups: aldehyde has 1 oxygen atom, alcohol and ketone also has 1 oxygen atom, but it's only applicable to alcohol. Right? Alcohols can be converted into ethers. So let me draw the alcohol structure. C3, 1, 2, 3 OH, CH2, CH2, CH3. Chemical formula C3H8O. This is called propanol. 1 propanol or propanol. Here alcohols can be converted to ethers. Ether general form functional group ROR. Alcohol general functional group general formula ROH. Please remember that. Here CH3O, CH2, CH3. Say this. So this you can write as alkoxy. This one is alkane. Alkoxy. That means methoxymethane. Methoxymethane. That means you can draw two possible isomers for the chemical formula C3H8O. One is propanol, one is methoxymethane. Methoxymethane. Okay, right? Alcohols are can be converted into ethers. Acids converted to esters. Ketones converted into aldehydes, whereas alcohols are converted into ethers. Right? Make a note. The last one is alkynes are converted into dienes. Alkynes are converted into dienes. That is, let us take butane structure. Butane means four carbon atoms with one triple bond. Butane. 1, 2, 3, 4. CH3. Chemical formula C4H. Yes. C4H6. Right. I would like to convert this structure into like this. I would like to write it as two double bonds. CH2, CH, CH, CH2. Total C4H6. C4H6. But name of this compound is 1, 2, 3, 4. 1 butane, but 1 comma 3 diene. 1 comma 3 diene. But 1 comma 3 diene. So this one is a butane. Butane can be written as but 1 comma 3 diene. So these are the functional group isomers. So please remember that acids can be converted into esters, alcohols to ethers, aldehydes to ketones, and alkynes to dienes. I hope you understand. So please go to the entire video and revise again and again. Then you will get clear picture about isomers. Thank you, my dears. Have a nice day.